Assalamualaikum and hi. So this one is a homogeneous equation by substitution. In the previous example, the differential equation are homogeneous. However, there are also differential equations which are not homogeneous. But by using appropriate substitution, it can be reduced to homogeneous and can be solved by using the methods. Okay, so we will look at one example over here. Okay, by using a substitution equation, x equals to capital X plus 1, y equals to capital Y minus 1. Find the general solution of this one. Okay, if you notice, this one is non-homogeneous, right? Okay, because of obviously you get when you try to prove f lambda x lambda y equals to fxy, you cannot have that. Okay, so this one is clearly non-homogeneous, but by using this one you can reduce this equation become a homogeneous equation. I show you the work step over here directly. Okay, so first thing is this one is given right in the question. First thing is you have to replace all the small letter of x and y to the capital letter of x and capital letter of y. Okay, so first thing is you have to find dx, d capital X. Okay, clearly equals to 1, isn't it? Can? Okay, so we know that dx equals to d capital X. How about dy over dy over here equals to 1? Clearly we have this one. So therefore dy over dx equals to dy over dx capital Y over capital X. Okay, so next step, this one is the question, right? Okay, so then dy over dx clearly you can have as d capital Y divided by d capital X. Okay, so the 2x over here you must replace by this one. Okay, same goes to the y, which is y minus 1, and write down everything. Okay, and then same goes to the denominator over here, and then when you simplify you will have new equation, new differential equation, which is this one. Okay, when you check this one, this is a homogeneous equation. Okay, so then now we go to the homogeneous step. Okay, remember this one is the standard equation, y equals to vx, but over here we will use capital letter of y, same goes to the v and the x. Why is that? Because of we have replaced the small x and small y by the capital letter of x and y. Okay, so this one is similar like before. We have to differentiate to have dy over dx equals to v plus x dv dx, and then replace everything. Okay, same procedure, and then try to start your separable equation method. Okay, and then move for one side. Okay, and then over here you will have 1 plus 2v divided by 1 minus v squared, and over here we have 2 divided by x. Okay, so now we focus on the first side, first part, which is this side. Okay, if you notice, this one, right, is quite tough to settle, to solve. So you have to think really critical, okay, and do a lot of practice. This question you can use partial fraction, where you have to factorize this one, become this one, and resolve to partial fraction, Okay, actually I have skipped a few steps and finally you will have this one. Okay, so this one actually you can have 1 plus 1 plus v 1 minus v. Since this was a single first order, so we have a b. Okay, so by using the step in partial fraction, I hope you can recall what this partial fraction is. Okay, and then you will have the value of a negative 1 and b as 3, and then over here you can integrate one by one. Clearly we will have half bracket minus ln 1 plus v, negative 3 ln 1 minus v equals to 2 ln x plus c. Okay, so over here advice to simplify, and then we will have this one. Okay, if you notice, again this one is ln 1 plus v, ln 1 minus v, ln x, ln d. Okay, where do we get this one? Because over here we just have c. Okay, we just create this ln d from the c. Why is that? Because everything is in ln, right? So easy for us to do some elimination if everything are in the ln term. Okay, we create this ln d is coming from the c, and then we merge the ln right and left, and then we can simplify like this. Okay, daripada sini, from here we can replace the v equals to y divided by x, same goes to this side, and then simplify. And finally, don't forget your original equation is r using small x and small y. Okay, so leave your final answer as simple as you can, and remember that you have to leave your final answer by using the original variables. Okay, so this one is the uh, the homogeneous equation by the substitution. You can try all this. Okay, so that's all. Thank you.